Hello, you absolute legends, and welcome back to Create Inc. Today, we talk about how to make some lithophane lamps, colored or otherwise. We take a look at the design process and a few design considerations, like what tools are used to design this and why is it the shape that it is. Why is this an equilateral triangle? Because all of this was made after careful thought. For my international viewers, I would also impart some ancient Indian knowledge to you, the philosophy of Jugaad. Fully parameterized CAD files for these lamps are available in the description of this video. There are two links, one for Thingiverse and the other one for Etsy. There is absolutely no difference between the files. If you'd like to support the channel, you can get it from Etsy for $1. Otherwise, it's available on Thingiverse for free. Now, before we get on with the video, I'd just like to say that on this channel, I try to bring original content to you. Everything from the graphics to the animations, and even the music is made by me from scratch. It can be inspired at times but never sampled. So if you like my videos, please hit the like button for the algorithm and subscribe to not miss future content. And with that, let's get started. For the design process, I had initially intended to do this in OpenSCAD. There were two reasons for that. The first one being that it's an open source and freely available software, and the second being that it allows a level of control on your model that is not possible with other software tools. I did start with it, but I abandoned it rather quickly. I'm way more familiar with Fusion 360, which is free for hobbyists and is easily available, and I realized that more people watching the video would be familiar with Fusion 360 than with OpenSCAD. As for some of the design considerations, one of the easiest and most natural shapes a person thinks of is a cuboid. But the reason for this lamp being prism shaped and not a cuboid is twofold. The first one being that I find triangular designs more aesthetic, and the second being that cubical designs would be much harder to 3D print. There are slots on the sides where the lithophane would be inserted. If it were a box, it would be very difficult to print this without supports. A triangle, however, is easy to print without any supports and also allows a nice slant to make it easier to look at, much like a photo frame. For the angles, I initially went with a slightly different design that I still feel looks better. Right-angled, longer base, but this had an issue. The base would always be longer than the lithophane plate. It might not fit on the build plate of your printer. If I make this an equilateral triangle, the base would always be the same dimensions as the lithophane plate itself, and you won't have to worry about it fitting on your print bed. As long as your printer can print the lithophane, it can also print the lamp body. Regarding the slots, I went for a slotted design because I did not want to involve the use of any screws, and I still wanted the lamp to be easily renewed with a new plate whenever the person feels like it. It also facilitates repairability. If an LED goes bad or something, it'd be easy to replace as long as you know how to solder. For the insides, I glued everything with hot glue, kind of a shortcut, because it's actually pretty easy to remove as long as you have a heat gun, so you can repair it whenever you want to. This also brings us to the philosophy of Jugaad. What is Jugaad? First of all, Jugaad is an informal term, a slang word. A bad translation of the word would be jerry-rigging or bodging, but neither of these terms does it justice. Jugaad is a cultural philosophy of dealing with constraints. It's imbibed into every Indian from a very early age. Everything around is one jugaad after another. You can say that this was life hacks before it was cool. You see, this is why Indians keep coming up with cheap space missions. In this project itself, I had to light up LEDs that take 4V DC as an input. Initially, I had thought I'd use an AC to DC converter, like this cheap module over here, but there was one big problem: heat. I would never put this inside an enclosure made of PLA. It might produce heat, and PLA and heat are not the best of friends. If I keep it outside, I'd have to buy some commercially produced enclosure that would have to be properly sized, and it's kinda tough to find one. So I decided to find some old USB cables that don't fully work. You know, the ones that would only work at a particular angle and require a lot of jiggling and delicate handwork. So USB ports give 5V DC by default, which can be reduced to 4V using just a resistor. Even if I were to sell these, every household has some of these adapters lying around. Some households even have USB ports built right into their switch ports these days. This saves me cost and the headache of sourcing enclosures and makes it easier for everyone. Of course, if I were to make this for a customer, I wouldn't recycle an old USB cable. I'd just buy a new USB header. So in the next section, I'd still show you how you can rewire an old USB cable to use in such projects. Now for the build. The build itself was fairly simple. I found some good pictures that I wanted to print. I uploaded them to lithophanemaker.com and downloaded my colored lithophane files from there. If you don't know how colored lithophanes work, I made a video about it and you can click on the I button to find out more. I imported these files into Blender. I put a border around all of it to make it look pretty and then exported it back. As I already told you, I designed the lamp in Fusion 360. These are the 4 parameters you need to change if you want to print one for yourself. Shown on your screen is what each of these means. You don't have to worry about clearances because I have already added them where they're needed. You just need accurate measurements of your lithophane plate. You can do it physically with a caliper, or you can just get it from the slicer as well. That is what I would recommend. Alright, then just go ahead and print everything and then we can talk about the electronics. I'm using a few of these cheap LEDs that you can find online. I'd leave a few links for these in the description for both Indian and international audiences. I used 2 of these LEDs. They are wired in parallel. That means that the voltage across the one on the left is the same as the voltage across the one on the right. Now, this is a slightly delicate part. You have to be very careful regarding the current draw and the heat produced. USB ports only give out 500 milliamperes of current. So if you aren't sure of how much current your LED bulbs would require, I'd always recommend you use a multimeter to find out exactly how much. I purposefully underpowered my LEDs by using a relatively large 500 ohms resistor because I would only use these lamps as night lamps and I really do not want to risk a fire. I also tested these by running them continuously for 48 hours and then checking if any of the LEDs felt warm to the touch. If you are not sure how hot is too hot, if after prolonged use you see that the hot glue has started to melt, that's a pretty good sign that it's very hot. Now for the USB cable, you snip away this thingamajig at the output end and then strip the insulation from the cable. You might find some metallic shielding on the wire, strip that away too until you're left with a group of 4 or 5 wires that look something like this. The red wire would always be carrying plus 5 volts and the ground would be a black one most of the times. But in this particular case, it turned out to be this uninsulated silver colored group of wires. That surprised me a bit too. But anyway, it's always a good idea to test the voltages using a multimeter as well. I used a 2-core insulated wire and soldered these LED pairs onto it in parallel. I connected all of it to the USB cable and tested if everything was working as it should. I soldered the other end to the USB cable and then glued everything together, and voila, we're done. You put in your plate and your lamp is complete. If you'd like to buy a personalized lithophane lamp for yourself or for a friend, you can find this on my Etsy store. The link is in the description. And with that, we come to the end of yet another video. If you liked it, you know what to do. If you didn't, the other one is fine. In the comments, you can let me know if you found the video useful and where I can stand to improve for my future content. Hit subscribe to not miss my future videos. And until next time, just keep building.